Good morning, all you Sioux High Earth Science students. Wake up! This is Mr. McLeod again. Welcome to part 2 of our series of podcasts on the rock cycle. No better example of earth science music than the boys from Scotland, AC/DC. Okay, so get your notes out, something to write with, and let's shake you all hour long. Woohoo! Okay, so we ended part 1 by starting a discussion of weathering and listed the 4 main types of weathering in your notes. So find that spot and let's start there. Remember, we're talking about the rock cycle. The process of weathering actually breaks up big rocks into little pieces we call sediments. Get that in your notes. We'll talk about the different size sediments later in this podcast. Okay, let's first talk about physical weathering. A really good example of physical weathering is freeze-thaw wedging, also known as frost wedging. Get that in your notes, and let's explain how that works. If you take a look at this slide, frost wedging, water seeps into cracks like you see here. You see water now seeping into the cracks in the rocks. We also know that water expands when it freezes. So this water starts to freeze and expands, and then it breaks apart the rock into sediments. So that's called frost wedging. Get that in your notes. Okay, now chemical weathering. Chemical weathering takes place in almost all types of rocks. In chemical weathering, chemical reactions break down the bonds holding the rocks together, causing them to fall apart into sediments. Get that in your notes. As you can see in this slide, this statue is kind of, lost face or lost its face, and some of the details of its body primarily due to acid rain, which would be a form of chemical weathering. So you need that example in your notes as well, so get it down now. Okay, our next process is called erosion. Erosion consists of 2 exogenic processes. There's the word exogenic right there. So get that in your notes. 2 exogenic processes, and then we're going to talk about those. The first exogenic process is water flow. The second exogenic process is wind. So get those down in your notes. Water and wind work to remove soil and rocks from one location on the Earth's crust, then transport them to another where they're deposited. Get that down. Now, very often, weathering and erosion are confused. Erosion is the transport process. Weathering is the breaking down process. So that's a misconception. All right, erosion merely transport the sediments with wind and water, where weathering is the actual breaking them down into pieces. You can see examples of this in this slide. On the left is the formation of the Grand Canyon from erosion caused by the flowing of the Colorado River. On the right, you can see evidence of wind erosion on these rocks in a desert. Make sure you have these 2 examples, in your notes. Okay, now on to transportation and deposition of sediments just created through weathering and erosion. By the way, make sure you get that AC/DC song down in your notes. It was Shook Me All Night Long. All right, sediment transport or transportation is the movement of solid particles. Remember, we call them sediments. Get that in your notes. So it's the movement of those sediments that we call transportation. This movement or transportation is typically due to a combination of 2 things. Let's get them in your notes. The first is gravity, acting on the sediments. And the second is the movement of the fluid in which the sediment is located. Also get that in your notes. So by fluid, we could mean water or we could mean wind. Remember that a gas is considered a fluid and the atmosphere is made of gas. So wind is really movement of the atmosphere. Now, sediments also come in many different sizes. Let's also get those in your notes. So look at the sediment grain size chart that you see right here. We're going to be talking about that here for a second, the sediment grain scale. There are 4 classes of sediments. Now I want you to know all 4, and I also want you to be able to rank the sediments from smallest to largest grain. Now this grain scale lists them from smallest to largest, left to right. So let's get those in your notes. The smallest sediments make up clay. In fact, when you see clay, there are no visible grains. So here's our smallest now, and you can see how small they are, less than a centimeter. No visible grains. Then that's followed by silt. Then fine sand, coarse sand, and then what we call gravel. Now gravel includes what you see down here: pebbles, cobbles, and boulders. So get those in your notes. So clay, then silt, then fine sand, coarse sand, and then gravel, which includes pebbles, cobbles, and boulders. Get those in your notes. Now I also want you to see how these sediments are deposited. In the bottom of the slide, you can see where they are deposited in a stream. So here's our stream now, and the water flowing in this direction. So I want you to kind of get oriented now as to what we're talking about. So the water's flowing in this direction. I'll show you a simulation here in a second too. The larger sediments are deposited first. And you can see them now right here, deposited right away just above the bedrock. Then those are followed by sand and silt and clay. So the largest particles, the largest sediments are deposited first, and then the smallest sediments are carried down further, obviously because they're lighter, less dense, and carried further. And then eventually, they're going to precipitate into what we call sedimentary rock, which we'll get to here in a second. So get that in your notes. Okay, now here's a great example of what we just talked about. You can see now the stream flowing now out into a larger body of water. You can consider like the Mississippi Delta as a good example of this. So the Gulf of Mexico would be out in here, and this would be the Mississippi dumping into the Gulf of Mexico. So you can see now these larger grains being deposited first, and the smaller grains now, the gravel-sized sediments accumulating near the shore, and then you have the sand grains and the silt and the clay carried out farther out into the ocean. So I want you to get a crude diagram of this in your notes. So you might want to go back. Let's go back to that diagram that we just had on deposition, and I'll let you write that in your notes. Hold on a second. Okay, so here's that diagram again. So go ahead and get a crude picture of this in your, or a diagram of this in your notes so I can see it when you turn it in. So just write the order and the detail that it has in here just like you see it. And then we'll move on once you get this done. Okay, so let's try and put this together and apply it to the formation of our first class of rocks, the sedimentary rocks. Now that you know what a sediment is and the different classes of sediments, you're ready to understand this process. Since it's a rock cycle, we have to start with some kind of rock to break into sediments. So in our example, we're going to start with an igneous rock, like the granite sample you see here in this slide. So right up here on the left is an igneous rock. One of the ways you can tell it's an igneous rock is it's shiny. We'll get into a bunch of characteristics of igneous rocks a little bit later in these podcasts. The igneous rock granite can be physically weathered to produce clay and sand, and you see this process over here. These particles now that are being weathered, you know the weathering forces, we talked about them. These particles now can be chipped off of this rock and carried by water or wind. Now, they're physically weathered to produce, in our example, clay and sand, but it could be any kind of sediment. But we're going to use clay and sand as an example. Now, these clay and sand sediments can be transported, deposited, and lithified. There's a new term, lithified, L-I-T-H-I-F-I-E-D, which means glued. Get that in your notes. Lithified means glued. They can be glued together to form sedimentary rocks. Now, in the case of clay, clay can become shale. So here's a great example of shale right here on the bottom left. So those clay particles, remember they're so small you can't really see them, can be glued together to form shale. And then the sand particles can be lithified or glued together to form sandstone, like you see here at the bottom of the slide. Chemical weathering actually dissolves the minerals in rocks. Write that down. The resulting compounds that have dissolved out of these rocks can actually form minerals like halite/rock salt that you see here in this slide, which is mined in Detroit, underneath the tunnel actually. When I was in elementary school, we used to take field trips to go see this mine. So there's halite that comes out of the rocks, or rock gypsum, like you see here on the right. This is gypsum, which is mined in Rogers City, big quarry in Rogers City that mines gypsum. And it can also become limestone, like you see here. Now, limestone is mined on Drummond Island and in Cedarville as well. So it's called dolomite, but it's still the same basic rock, limestone. So get those three examples in your notes. What forms actually depends on the composition of the rock and some other environmental factors. Now here in Michigan, we live on top of a complex group of sediments that were deposited by glaciers. Get that in your notes. Now the question is, what kind of rocks will these sediments become? We'll talk in more detail about glaciers, but let's just talk about some glacial basics. Glacial deposits are much younger than the bedrock they sit on, like is seen here in this slide. So here you see the glacial deposits, and there's the bedrock that they sit on. So these glacial deposits are much younger, which makes sense. The bedrock would be a compressed version of these sediments right here. So, and they'd be deposited by the glacier on top of each other. So those are much younger than this bedrock that's underneath. Make sure you get that in your notes. Now, most of us know that our state stone is the Petoskey stone, like you see here. The Petoskey stone is a fossil coral that lived in the ancient seas some 375 million years ago. Get that in your notes. Now, the rocks that formed in that environment that long ago were mostly limestones, and Petoskey stone is a good example of a limestone that's made of fossils. All right, that's it for part 2. Take a picture of those notes that you just wrote. They're beautiful. I'm really happy with the notes that you guys are getting. Send it to Moodle, and go grab the study guide questions for part 2. Get those done and submit those as well. Talk to you soon. Bye.